Let's look at an example where we're asked to find the standard form of an ellipse given some of the characteristics of that ellipse. In this example, we have an ellipse that has foci at the points 3, 6 and 3, -2. And then we're also told that our ellipse has a minor axis of length 6. So I'm going to start this out just by sketching a quick graph of the information that we're given. So let's see here. Here's 3, 1, 2, 3, 4, 5, 6. So here's 3, 6. That point right there is one of our foci. And then 3, -2, there's our other focus. And then we have a minor axis of length 6. And before I can add that on the graph, first thing we need to do is find our center. Because my foci are positioned like they are, I know that this is going to be a vertical ellipse, which means that when I get to the standard form, let's just go ahead and write that down as a reminder. X minus h squared over a squared plus y minus k squared over b squared equals 1. I know that because this is vertical, this number is going to be the larger number. Our b squared is going to be bigger in this case. So let's find our center. The center needs to be halfway between the two foci. And, excuse me, since we know it's going to be along this vertical line, we know that the x-coordinate of the center is going to be 3, just like our two foci is 3. And so I need to find the halfway point between 6 and -2. Now we could count that on our graph and figure it out, or we could do the math. 6 minus -2. 6 minus -2, that of course is equal to 8. And if I divide 8 by 2, then we're going to get 4. And so that means that our center is going to be 4 units away from each of the foci, which is going to place it right here. And so our center has the coordinates 3, +2. So now we can do our minor axis. It has a length of 6. The minor axis is the shorter axis, and so that means it's going to go out, we're going to go out 3 from the center in this direction, and that wasn't the best place for my coordinates. Move those out of the way. And then 3 in this direction. And so now all we need to know is the length of the major axis. This value here of 3, that gives us our a here in our standard form, the number that we're going to square and put under the x squared term. We have our h and our k from the center, so all we need is that b. Now remember, whenever we're missing A, B, or C, C being the distance to a focus from the center, whenever we're missing one of those numbers, we're going to set up a Pythagorean relationship. And we always want to ask ourselves which one of those numbers is going to be the biggest. In this case, the largest number is going to be the one that we're looking for, which is the b. So b squared is going to be equal to a squared plus c squared. So in this case, our a squared, we have figured out that our a is 3. That's the distance from the center to the end of the minor axis. So this is 3 squared. C is the distance from the center to a focus, which is this distance here, 4 squared. So b squared equals 9 plus 16, which is 25. And so b is going to be the square root of 25, or just 5. And so now I believe we have all the information that we need to write our equation. We have our center is at 3, 2. So I'm going to have x minus 3 squared plus y minus 2 squared over, in the x direction from the center, we're moving out 3. Sorry about that. 3 squared. And in the y direction, on our major axis, we're moving out 5 in each direction. We're going to square that, equals 1. And so that's our standard form equation. Another acceptable version of this equation would be to have 9 and 25 as the two denominators.